Cathy Webb, and she will give a talk entitled Seafood Safety and Our Changing Environment. I'll give you about 2 minutes.
All right, kura koutou, ko Cathy Webb tōku ingoa. So I'm Cathy Webb, I'm the GM of Seafood Standards and Market Access for Seafood New Zealand. Right. So today I'm just going to give you a very quick outline of a couple of recent events that may have occurred due to changing environment impacting on seafood safety. First one I'm going to talk about is Vibrio parahemolyticus, and the second event I'm going to talk about is a paralytic shellfish toxin event that had a significant impact on our rock lobster sector. I'm also not talking about the science or the research, and so again, no curly questions for me, but however, if you do have questions, talk to Graham about Vibrio and to Tim about PSTs. And on that note, I would like to also acknowledge Graham Fletcher for sharing his Vibrio research and slides that he gave at an earlier conference that I've plagiarised. So first, what is Vibrio parahemolyticus? So it is a naturally occurring marine bacteria found in coastal environments around the world. It's not related to human pollution. Most strains, thankfully, are not pathogenic, but some are, and cause gastroenteritis. It is the leading cause of seafood-associated illness worldwide, and there is an increasing number of reported cases. There's a higher prevalence and concentration in warmer months and in warmer waters. So traditionally it's detected in filter feeding shellfish and predominantly in oysters. It is a bacteria, thankfully, that's relatively easily killed by heat, and New Zealand as a whole hasn't had a history of VP illness despite it being detected here since the 1980s. That is until 2019. So in 2019, between early May and late June, we had 24 cases of VP illness that came from the consumption of mussels from the Coromandel. 2020, something similar, so June to July, 16 cases, also mussels from the Coromandel. And in 2021, slightly different time frame, but through that late summer, early winter, February through to May, 16 cases, again from mussels taken from the Marlborough Sounds. We always knew that we would have Vibrio parahemolyticus illness at some point in time in New Zealand, but we always thought that our first incident would be in summer and it would be in oysters, certainly not in winter and not in mussels. One of the things that I think that we were completely unaware of was the amount of mussels that are consumed in New Zealand in their raw state. We know oysters are consumed raw, but we kind of always assumed that mussels would be consumed further cooked. So while this is not a great situation, overall the number of cases were relatively low. But then this happened. So between November 2021 and May 2022, we had 60 cases of Vibrio parahemolyticus illness reported, and they ranged from around the country, from Dunedin all the way up to Northland. One of the interesting factors, and again it's the sciencey question for Graham, but there were at least 12 different strains were sequenced across those cases, and that is quite unusual. Usually outbreaks are linked to one or two strains at the most. The majority of the seafood was recreationally caught. There were a small number of commercially purchased seafood that were also included in the case numbers, but most cases were from the consumption of raw seafood rather than cooked seafood. But 42% of those cases sought hospital treatment, so it had a relatively high impact. But this was even more surprising. The range of seafood implicated in these cases was significant. So finfish, rock lobster, paua and bivalves were all implicated. And this is also extremely unusual. So in comparison, Australia in one of their recent or later outbreaks of around 200 cases all came from oysters. So the range of seafood implicated here is significant. So what was going on in 2021? So 2021 was a very hot summer, the 5th warmest on record overall. Seawater temperatures were high, particularly around the northern eastern of the North Island. It was the highest on record that year, although clearly we've had higher since. But the other thing that was interesting is that New Zealand just came out of lockdown. So we were out of lockdown, but we weren't able to travel overseas very easily. So it was a lovely summer, everyone was at the beach, and they were collecting their kai. What we don't know, though, is was this a new experience for them, or what was the level of experience around food safety, right? Around cold chain management, around cross-contamination control. So is it the changing environment, the warming sea temperatures to blame, or some other environmental factor, or was it due to the people not following these good food safety practices? The short answer is we can't say for sure. But I think what we can say is that we know that the changing environment is having an impact on seafood safety, and certainly with respect to Vibrio. So I'm going to switch examples now. I'm going to talk about paralytic shellfish toxins and rock lobster. So what are PSTs? So paralytic shellfish toxins, or PSTs, are produced by naturally occurring marine phytoplankton during algal blooms. The toxins accumulate in filter-feeding shellfish, which cause illness in humans. The toxins are not destroyed by heat, so cooking's not going to remove this as a risk. But then they also accumulate in the gut of rock lobster as the rock lobster then consume the shellfish. So how do we as an industry manage this? So we have a national management plan for rock lobster. It was developed in the early 2000s. And while it's an industry-run and industry-led program, it has MPI recognition for risk management. It's based on utilising the data that's collected through commercial shellfish testing in commercial growing areas, and also through the recreational sites that are tested regularly on a weekly or 2-weekly basis around the country. The plan itself triggers us to sample when the threats are emerging or when public warnings are issued. It requires us to close the commercial lobster fisheries, so to close them to lobster fishing if the lobster gut itself reaches above the shellfish regulatory limit. And the purpose is designed to protect our trade and public health. It's important to note here that the toxins only accumulate in the gut, they don't accumulate in the edible flesh itself, but we also know that many New Zealanders eat that gut, or they use it to make stocks or soups or bisque and things like that. So it's really important for us to make sure that we're managing that risk. So these PST events have actually been impacting the rock lobster industry since about 2012, and we've had small events that have occurred in localised areas over the last, every year essentially since. But they generally they're smaller areas, they are not significant in terms of duration, so the events last around the 2 to 4 weeks, sometimes longer mark in terms of how long a lobster fisher needs to be out of the area. But in October 2023, an event occurred in a localised area around Tokomaru Bay, and it was placed under public warning due to the PST, the levels of shellfish. The levels of toxins in the shellfish over the regulatory limit. However, within a month, that algal bloom had extended both north and south to include the total area from Blackhead Point in the Hawke's Bay through to up to Cape Runaway in the Bay of Plenty. This was the final area that was under warning. This was the totality of the area that came under public warning for several months due to PSTs. So as the algal bloom extended both up and down the east coast, the toxicity of the shellfish increased, as so did the toxicity in the lobster gut. In fact, we took samples of lobster that ended up nearly 10 times the regulatory limit during that event. The entire area was under warning, so was closed to commercial lobster fishing. This is no small feat to manage every lobster fisher, to have them out of the water for that in an area of that significance spatially. So the event continued through December, over Christmas and into January, before the algal bloom started to dissipate and the shellfish then depurated. However, the lobster took significantly longer to depurate than the shellfish did. We opened the first area back up to lobster fishing back in late January 2024, and it was a small area around the Mahia Peninsula. The last area to opened on the 20th of June, so only a few weeks ago. And it was also the first area to close. It was the localised area around Tokomaru Bay. So this was also after some 1,200 lobsters taken for testing at a cost of over $100,000. The testing cost is fully paid for by the industry, and that is nothing on the total cost of the impact on that sector in terms of, for some of those fishers being unable to fish for 7 months is significant and a financial impact for them. So, did Cyclone Gabriel have an impact? Okay, the short answer is we don't know for sure. But as this has been the longest, most widespread PST event that has impacted the rock lobster sector, taking some 7 months before those rock lobsters depurated fully and returned back to safe levels, and the area of the algal bloom itself was the same area that was impacted by Cyclone Gabriel. We've all seen today photos of the impact of the cyclone on the land, but we'll see here some images of the impact in the sea. The top couple obviously show the outfall, and the bottom three show the sediment that's ended up on the seabed along with some of the other debris. So as you can see, a significant amount of runoff, silt, nutrients and other debris went into the coastal environment. And I think that's one thing that's kind of important to remember. We often talk about what happens on land. However, we also should remember that what happens on land impacts our coastal environment somewhat significantly. We know algal blooms are caused by overfeeding of nutrients, mainly phosphorus, nitrogen and carbon, and also from pollution from other human activity. So it's highly likely, well certainly likely in my opinion, that the impact of Cyclone Gabriel also had played a part in this event. And thank you for that. And just again, acknowledging Graham, but also MPI in terms of some of the Vibrio information.